This conference will now be recorded.
Okay. All right. So let's start off with the non-functional requirement. So yesterday we started off with the non-functional requirements and we arrive at them. Today we're going to talk non-functional requirement, how it will be, and then we will talk about how to document these non-functional requirements. So what are the criteria? So what would be the metrics with which we should be able to capture these things? Now, when we talk about the user concerns are from the performance perspective. The ease of using the application is secured, the availability of the application, the performance of the application, ease of connecting with multiple applications, and so on. So when you put down those things into the requirements and you translate these things into the requirement, ease of using translate to user friendliness, is secure translate to security of the application, is available, so it translates into the reliability of the application and so on. Now, when we have to classify the requirements into the functional or non-functional requirements, so these are some of the examples of the non-functional requirements. So, for example, if I say the system should be able to help the user in raising a help desk incident, help desk is when a particular system is down, when a particular unable to, user is unable to access the system for some reason. So the user should be able to do something to do to be able to access the application. So what do they do? There is a help desk ticket. So that means that there is a ticket that is raised with a system which is going to be a help desk application or something like that. So if you look at to that particular requirement, that's going to be a proper functional requirement. So that means that you have a step-by-step sequence of things what you would be doing in order to raise a help desk ticket. But when we talk about the non-functional requirements as such, so here are some of the examples which says that the product will support multiple languages. Product will support multiple languages. So on a high level note, it seems to be a functional requirement. People say that okay, so the product should be configured to have multiple languages supported and so on. But that's not a functional requirement. It's a proper non-functional requirement. And when we say non-functional, then the question arises is what kind of non-functional requirement is it? Is it related to performance? Is it related to security? Is it related to user friendliness? Is it related to availability of the application or portability? So there can be a number of non-functional requirements. The moment you say that product will support multiple languages, it's related to the user friendliness of the application. It's related to the user friendliness of the application or usability of the application. The system will run a 7 days a week, 24 hours a day. The system will run 7 days a week, 24 hours a day. It's a reliability related requirement. So that means that your system is always available. An online help system is required. An online help system is required. Again, that is a user friendliness related requirement. So why do we need online help? So to make things easier for the user. So that becomes a user friendliness related requirement. So that way when we are classifying the requirement, we should be able to segregate the requirements properly, whether it is a functional requirement or a non-functional requirement. According to that, we should be able to segregate and put it in the form of the requirements. Okay, is that clear?
Yes.
Okay. So another important distinction I would say is the functional requirement. You have generally a workflow. For a functional requirement, you will have a workflow. Workflow is a step-by-step sequence of things that the other day we looked at with regards to the use cases and so on. Obviously, use cases are written for functional requirements. So the step-by-step requirement, step-by-step thing, workflow that is written under the success scenario. So that will be related that are related to the functional requirements only. For non-functional requirement, you don't have such workflow. Remember, you won't be having such workflow at all for non-functional requirements. So If you talk about the product will support multiple languages, uh, there is no step-by-step things that we can do. It is just a configuration. You go to one particular table or a configuration and configure it to support a language. It can be English, Spanish, however. So that way, it is a setup. It is nothing to do with the workflow for making sure that it supports multiple languages. So that means that for non-functional requirement, you don't have a workflow. So now if you say the system will run 7 days a week, 24 hours a day, there is no workflow. Workflow in the sense, for example, if I want to withdraw, the other day I was showing you the step-by-step things in a flow chart. So withdraw the cash. So in that case, I have step-by-step things. I insert the card, enter the pin, and so on. So which is not there here. So that kind of workflow will not be available with regard to the non-functional requirements of a system. So please remember that, and while categorizing your requirement, you remember that okay, so can I put it in the step-by-step format? Okay, if it is not possible at all, then it is a non-functional requirement. The chances of it becoming a non-functional requirement is more. So the performance of the system should be high, or maybe like 20 seconds or 30 seconds for doing a particular transaction. Does it have any sequence of steps to do that? No. Okay, so that way the non-functional requirement doesn't have a workflow so similar to a functionality, and the challenge is there. That is why it is not that straightforward to document the non-functional requirement like the functionalities. It is not that straightforward like functionalities. So that's where we need to come up with some metrics of the performance data. And one other understanding that we should be having, these are not pure things that are done by the business analyst. These are to be done in relation with the technical teams. In relation with the technical teams. Now, performance needs to be improved by 20%. For example, for existing applications or transactions, we need to improve it by 20%. So for that, you have to have maybe additional servers. You have to have the system capacities need to be upgraded. So all those things are more technical things that the PA cannot or may not have the understanding of it. So that's where non-functional requirements are more of technical related things more involved in that. Okay, but anyway, so for the definition of the requirement, we should be able to define the requirements with regards to non-functionalities. So the business needs is that the system should be available during working hours and non-working hours. The business need says that the system should be available during working hours and non-working hours. So the objective is availability of the system. Metrics are the performance data is number of planned outages, number of unplanned outages per month or per year, number of hours per outage. So if the system goes down, how many hours it goes down? Is it going to be 2 hours, 3 hours, 4 hours? How many hours it goes down? Planned outages per month or per year. So when we are developing the system itself, we need to have a plan in mind that how many planned outages we'll be having, how many scheduled outages, how many unplanned outages, unplanned downtime. So what would be the unplanned downtime? So that should be identified under availability. So that's one metrics with which we can define that requirement. The system should be available all the time, and there are two planned outages per month, and there will be two or three limitation of two or three unplanned outages. And if it goes down, it goes down for an average period of 4 hours or 5 hours. So availability, ability to restore all the transactions to a point in time prior to a failure, how many minutes, days, hours it will take to restore all that. So maximum time required to restore the configuration of session data, all the data related stuff to restore everything. What would be the maximum time that is needed for your system? Maybe 5 hours, 2 hours, or 3 hours, whatever. So that defines the availability as a requirement. So the system should be available 24 by 7, 365 days. There are two planned outages, and there should not be more than three unplanned outages. And the maximum time the system should be taking to restore all the session or configuration data should be 5 minutes, sorry, 5 hours. So 5 hours. So to restore everything, to restore everything from the if the system is crashed. So that becomes your availability related requirement. Is that clear? Mommy, Divya?
Yes.
All right. So coming to the efficiency of the application, the system should be efficient enough, and the business needs is that the system should be performing fast. We should be able to perform the things fast. So objective is the response time. Response time for simple transaction, medium transaction, and complex transactions. Simple, medium, complex. What is meant by simple? What is meant by complex and medium? There is nothing like that simple, medium, and complex. But then, depending upon the number of steps, for example, if a transaction is having 1 to 3 steps, 1 to 3, so either one step or two or three, or a transaction having more than three to and less than five and greater than five steps. So we call it as a complex transaction, medium transaction, simple transaction. So that's how you segregate the transactions into simple, medium, and complex transactions. So then again, you put down some time. So for every transaction that is done by using the system, you put down into one of these three categories and put down a time. If it is a simple transaction, it should be done within 3 seconds. Medium transaction 6 seconds or 10 seconds, something like that. You come up with some time. So that the reason under that is that, so if you put some time for that, if you put some time for that, so you while you developing the system itself for all the transactions that are like between 1 to 3 steps, you make sure you follow this particular thing. So you develop the system in an efficient manner. So in efficiency also has one other perspective that is called the capacity perspective. So capacity perspective says that number of people who are using the system, concurrent users of the system, number of total users who are using the system, number of transactions supported per day, number of transactions supported per day. Is it like 10,000 transactions or 20,000 transactions or whatever? Efficiency can also be defined in terms of capacity, number of people who is using the system parallelly, number of total users who are using the system, number of transactions supported per day, number of transactions supported per day. All that would go under the type as an efficiency, so which talks about the performance of the system. So 3, 6, 10 are just the random numbers. There is no standard like that. But then again, it depends upon your application, how much time a simple transaction you would like to define for a simple transaction, medium and complex transaction. Is that clear?
Yes.
Yeah.
All, all right. So, yeah. Any questions? All right. So when you talk about performance, you can probably measure in like in some way like this. You have the serial number, your transactions defined, you have the use case reference for the transaction and response time in milliseconds, total users, concurrent users, and all that stuff. So this is for the internal people during the peak time, that is peak working hours, and this is during the off peak time. So during the off peak time, just give me a moment. Okay. All right. So when we talk about the performance, you have the internal users of the application and external users. For example, if you take a banking system, who are the internal users? Obviously, the employees of the organization. Who uses the system? The bankers, the personal bankers, and the help desk people, and then branch managers. They're all the internal people. And the bank system also used for the external customers like you and me, who has the bank account. So in that case, so if the external people also using for doing a particular transaction, how much time it is taking, especially during the working hours and during the off-peak hours, how much time the transaction is being done. So calculate that average, come up with the values, and then compare with your whatever the standard that you define here for a simple, medium, and complex transactions. Simple, medium, and complex transactions. So that's how you can properly plan it accordingly. So that way you can define a performance as one of the non-functional requirements. Then we have the supportability. The business need says that the system should be supported all the time. We need support all the time, right? So whenever the issue comes up with the system, so we should be able to get back to the technical team or the support team and get the things done for us. The objective is that to support all the maintenance activity. Number of support calls expected during the month. Number of support calls expected out of office hours, and supportability in terms of response time for critical calls, the response time for high priority calls, response time for low priority calls. Critical, high priority, and low priority calls. So critical is in the sense obviously which needs a quick fix, and high priority is something which is also like important but can wait for some time for the fix. Low priority is something which can be done in a sweet on time. There is no like urgency to complete that aspect. So that way when we talk about the supportability, so response time for critical, response time for high priority, response time for low priority calls. The scalability, so when we talk about the scalability of the application, percentage increase in yearly volumes for next X years. Percentage increase in disk number of users for next 6 years. So supportability also has another perspective which is regards to the scalability of application. How much the scalable the systems are. The percentage increase in yearly volumes for next 6 years. The number of users for next 6 years. Percentage increase in the disk space required yearly for next 6 years. So that basically talks about the scalability of the application. The scalability of the application. And with scalability also comes under one aspect of the supportability. One aspect of the supportability. So that way, supportability, when we talk about the supportability, so it says that the system should be supported all the time. And what are the expected, like what is the standard that we want to define for the support calls during the month out of office hours? And main importantly, what is the SLA, service level agreement, or turnaround time for response time for critical calls, high priority calls, and low priority calls? That becomes an important aspect. And we should define that, not the customer or the customer agreement. That's a different thing. Once the system is up and running, you once you onboard your customer, they will have the expectation that you will give a quick response. Your team will support the application like 24 by 7 and so on. 24 by 7 and so on. So that is about the supportability of the application. Is that clear? Any questions regards to this one? Hello? Is that clear?
Yeah.
Yes.
Okay. So coming to the security, one of the other important non-functional requirement is security. So what business says that protect sensitive information from unauthorized people accessing it, from unauthorized people accessing it. The objective is confidentiality and integrity. The system is protected from unauthorized people accessing it. Availability, time to restore, clean, restart, compromise system or the data. Time to restore, clean, restart, compromise system or the data. Compliance with the regulations and industry standards. So the system is compliant enough with the industry regulations or not. So obviously security to an extent is kind of manageable. Manageable in the sense it's not easy. It's just that security wise there will be industry wide standards. If you're talking about your debit card or credit card, you have like one level of security or two levels of security and all. That is the industry wide accepted standards. So already there will be standard defined. So if you have to run a business of credit card, you have to make sure your credit card things are like complying with that rules and regulations. Your systems are complying with those rules and regulations. So that's where when it comes to security, there will be like the industry leaders and there will be like the regulations that define the standard and we should go by those regulations. That's it. So that way when we talk about security, security talks about protecting sensitive information from unauthorized people accessing the application. Is that clear? Any questions so far?
Yeah, it's clear.
Yeah. So now coming to how we can link up your non-functional requirements with the use cases. So other day we talk about use cases. Use cases are written for functional requirements, while non-functional requirements are related to performance, security, and so on. So if you talk about the non-functional requirement, you have to relatively talk about non-functional requirement in relation with the use case because there will be a number of non-functional requirements and developing all of those things for each and every functional requirement, it's not going to be possible, not feasible. So that is why for each and every functional requirement, what are all the non-functional requirements that are important that we need to identify and put it in a tabular format like this. So for example, there is an information submission screen which is related to like for example, you are trying to create a Google Gmail account. You put in n number of details and try to or you're applying for a job in an online portal, Indeed portal, or anything. You have to put in so many details. While putting in so many details, what's your expectation? The system should be user friendly. That's what your expectation is. So if you are while filling in the details, if the details are like the application itself is not very supportive, in that case, is it going to be easy for you to input the details? Is it going to be easy? No. Is it going to be like is it going to be friendly for the user to enter all the data? No. So the moment you feel that, what you'll do, you'll try to switch on, switch off to a different application, right? So which is like quicker, which can be feasible, which you can understand and you'll be able to fit. So that's why user friendliness is very important with regard to information submission screen. And performance is also very important. You have to fill in 3 or 4 pages of data. The system is very slow. You don't like to do it, right? You will not be able to do it. You will not like to do it. So that is where like a usability or the performance are the important ones. Hex with the red background. So defines is very important thing. While reliability, supportability, security, and all, so some of them are important but not very. So similarly, making payment. For making payment, what are you worried about so much? You are worried about security of application. You want the system to be highly secure while making the payment. The other things are important, but not very important at least. So while we defining the requirements, and while the developer developing these requirements, for making payment or payment related requirements, they need to make sure whether the proper security features are implemented or not. For generating the report, EOD report or like transaction report or whatever. So it is an end of the day one. So not very important it may be. So EOD report not going to impact the business directly, not going to impact maybe. So that is when, like in that case, you can say it is a low priority item. It may be low priority item. So that way you can put down the non-functional requirement in one side and use cases on the other side and identify for each non-functional requirement what are the things which are kind of important and what are things we need to consider. So ultimately, who will benefit by defining these non-functional requirements? Who will be benefited by defining these non-functional requirements? Ultimately, everyone in the organization. We talk about the business, for business team, tracing the non-functional requirements, for management, cost saving and financial planning, architect team in defining the right architecture and capacity planning, solution and design team in designing and development of the application, testing team in defining the test cases and achieving user acceptance of the application, infrastructure team in provisioning the right infrastructure, operations team in meeting their service level agreements, in meeting the service level agreements or SLAs. So that way, by defining the non-functional requirement in the early stages of the project, will help the businesses in like making sure it helps in cost saving for the organization and financial planning, in design and development of the application, in defining the right test cases and achieving user acceptance, in provisioning the infrastructure and so on. So that way everyone would benefit by defining the non-functional requirements for a system. Is that clear?
Yeah.
Others?
Okay.
All right. So that's about the non-functional requirements for a software application. What I want you to do is, I want you to go about like in our mind, check about these non-functional requirements, look at these non-functional requirements, and try to relate these non-functional requirements with the applications. For example, you may be having a Citibank account and HSBC account, bank account. You open two UIs and see the look and feel, and you see the user friendliness, you see the performance of the system. You see, compare all of those things and try to put down your understanding. So, which one is better in terms of things? Which one is better in terms of the things and so on? Is that clear?
Yeah.
Okay. All right. So that's about the non-functional requirements for a software application. And just give me a moment. Let's move on to the UML diagram, UML or UML diagrams. Just give me a moment. Okay, so moving on to the UML diagrams. So the last time, what was the last one that we discussed about UML diagrams? I remember we started off with the use case diagrams and we looked at the use case example, right? So any other things that we have looked at? The activity diagram, class diagram, and sequence diagram. Okay. Anyway, so I remember we discussed about the use case diagram where we talked about the actors and the use cases for a software application. Actors and the use cases for a software application. So the other day we were looking at the ATM machine. So that can be used by the different user groups. And one is the customer, the other one is the maintenance person, and then they use the system for withdrawal of cash, depositing the fund, filling in the cash in the system. So all these purposes they would be using the system. On the other side, you have the bank system, which gets updated for every time a transaction is being done. On the other side, you have a bank system which gets updated every time a transaction is done. So that means that we have the actors, we have the system, we have the purposes. The purposes are called as the use cases, and the that can be presented on a high level note, which tells us who are the users and what is their purpose of using the system. Now, when we talk about the activity diagram, so it is one of the important diagrams in YAML to describe the dynamic aspects of a system. It describes the dynamic aspects of a system. Activity diagram is basically a flow chart to represent the flow from one activity to another. So the control flow is drawn from one operation to another. This flow can be sequential, parallel, or concurrent. It deals with all the types of flow control by using different elements like fork and join, etc. Different elements like fork and the join, etc. So that means that EML activity diagram is kind of a flow chart which is used for defining the sequential flows, parallel or concurrent flows of the system. Parallel concurrent flows of the system. It deals with all the types of flow control by using different elements like fork and the join. Different elements like fork and the join. So let's have a look at how the flow chart, so the activity diagram would look like. Activity initial node, so that is represented by the dark circle. Activities are represented by rectangles. Activity final node is represented by the dark circle inside a circle. Dark circle inside a circle. Initial node, edge are the control flow. The arrow marks represent the edge as the control flow. And the activities, these rectangles are the activities, and the activity final node. In flowchart, it is similar to ellipse or the oval for starting activities in rectangle, and the final node is also again oh, so the final node is also similar to the start symbol. So that way eclipse are the oval. So that way when we talk about the notations, you have the notation something like this with regards to the activity diagram. Now we talk about the activity diagram, so you have something like this. So you have the two additional symbols like fork and the join. And how do you define a fork and the join? Fork is a point where a sequential flow is dividing to form a parallel flow. That means you have one sequential flow which is forming a parallel flow. That is when it is called as fork. Join is something like a parallel flow is combining to form a sequential flow. That is when we call it as a join. That is when we call it as a join. So sequential flow dividing to form a parallel flow. That is when you call this symbol is called as a fork, and this one is called as a join. So we'll anyway look at an example so which makes things a bit more clear. Now the purpose of the activity diagram, it is used to show message flow from one activity to another. It is sometimes considered as a flow chart, and additionally it shows different flows like parallel or concurrent and a single flow. So it supports sequential flow anyway. and it also supports the parallel flow, as simple as that. So steps while creating the activity diagram. So when we create the activity diagram, the first and foremost thing is to draw the activities of the system. So when do we need it? Especially like when we are defining the requirements, the business requirements at a high level, when we are identifying the different users and the workflows, that's when we can define a flow chart or probably an activity diagram. Activity diagram makes much more sense because it's more related to bit more technically oriented. Well, functional diagrams or flow charts are kind of easy to understand for everyone. So when you talk about the activity diagram, while creating the activity diagram, first this draw the activities of the system. Draw the activities of your system. Describe the sequence from one activity to another. One activity to another. Describe the parallel or concurrent flows of the system. Describe the parallel or concurrent. So wherever there is a parallel possibility or concurrent, so you define that parallel or concurrent flows of the system separately. Describe the parallel or concurrent flows of the system. So before drawing an activity diagram, we should identify the following elements first: activities and their association and their conditions. Activities, association, and their conditions. So one important point should be clearly understood that activity diagram cannot be exactly matched with the code. It is made to understand the flow of activities and mainly used by the business users. And mainly used by the business users. Okay. So now let's look at an example here with regard to the activity diagram. The following is an example of an activity diagram for online shopping. So we are trying to have a activity diagram for online shopping. The following diagram, okay, the following is an example of an activity diagram with online shopping. The following diagram is drawn with four main activities. The user would search for the item, add the item to the shopping cart, add the item to the shopping cart, confirm the order and receival of the order, confirmation of the order and receival of the order. So when you talk about activity diagram, so the following is an example. So the major activities for the activity diagram is the user would search for the item, add the item to the shopping cart, confirmation of the order and receival of the order. So now if you look at here, this is the activity diagram with regards to buying a product online. So the activity initial node that is represented in the dark circle. Activities are represented in rectangle. Search the item here, and like what we would do, we would put a keyword and click on search. So if the item is found, you have a decision box here. If the item is found, you have workflow like this. If the item is not found, you have to come back and you have to put a different keyword and search. And once the item is found, view the item, add the item to the shopping cart, add it to the cart. So once it is added in the shopping cart, you have two options: either view the shopping cart or edit the shopping cart. So there are parallel options. Either the user can, there is no sequence in it. If you are two people are using it, one person may be viewing the shopping cart and one person may be editing the shopping cart. So it can happen that way. Confirmation of the order. So the user would confirm the order and go to the payment gateway. So under the payment gateway, you have multiple payment mechanisms: credit card, PayPal, and all that. And shipping of the order and receival of the order. And this one is very clear. So the user would make payment by using any of the alternative flows. will not use all the flows. We will be using any of the alternative flows, either through credit card or through PayPal or anyone, any option. So shipping of the order, user can shipping of the order and receival of the order and receival of the order. With that, the process comes to an end. So that way, when we talk about the activity diagram, so the user would search for the item, view the item, add the item to the shopping cart. So view the shopping cart, edit the shopping cart, confirmation of the order, and once you confirm, it will go to the payment gateway. So payment can be done using credit card, PayPal, or any of the payment gateway, and shipping of the order and receival of the order. So this is the sequence. Is that clear? Is the sequence clear?
Yes.
Right. So there is a slight variation for the activity diagram, and here you are seeing the vertical lanes. What are these lanes? These are called as swim lanes. In the programming world, these are called as swim lanes. What are these swim lanes are used for? It is basically visually distinguishes job sharing and responsibilities. Job sharing and responsibilities. For example, the same example, but slightly in a different way. What are all the customer responsibilities? Customer would request for the service, would make the payment and receive the order. While the sales team would take up the order and delivery of the order. And the stock room or the warehouse team, they would use their purpose is to fill the order. Whenever there is an incoming order, they need to fill that order. So that way, a swim lane diagram is a visual element used in the process for diagrams or flow chart that visually distinguishes job sharing and responsibilities for sub-processes of a business process. For sub-process of a business process. So that way, when we talk about a swim lane diagram, it is used in the process flow diagrams or flow chart that visually distinguishes job sharing and responsibilities for sub-processes of an existing business process. The process of an existing business process. That's where the swim lane diagrams are used. So the uses of the activity diagram. So when do we use this activity diagram? So majorly we talk about the activity diagram. The following are the main usages of the activity diagram. Modeling the workflow by using activities. So modeling the workflow in the sense you can define the workflow, you can model the workflow. Modeling of the business requirements in a high level way, you can define the business requirement in a activity diagram. High level understanding the system functionalities. Investigate business requirements at a later stage. Investigate. So if you have workflow, you can define the workflow. Then you can keep it for the future reference and you can investigate whenever there is a problem or a challenge. So that way, when you talk about the activity diagram, so it can be used for a number of purposes and majorly to define the workflow, analyze the workflow, and understand the high-level requirements of the system. In all these cases, we can use the activity diagram. Is that clear? Any questions?
Yeah, it's clear.
Okay. Right. So in the next session, we are going to talk about two more diagrams. One is class diagram, the other one is the sequence diagram. So anyway, these two diagrams are not very important from the BA perspective because they are more technical things and more sensible for the development team. But these two diagrams are kind of important to understand wherever like the developer creates these diagrams and they use it, we should be able to comprehend the information whether it is correctly drawn or not. That's where we'll talk about the class diagram and sequence diagram. So that will be in the next session. And followed by that, we will talk about SQL, like how to write those queries to get the data from the database and so on. Okay. Any questions before winding up the session for today?
No.
No, I'm good.
All right. Thank you so much and see you tomorrow.
Thank you, Kiran. Bye.
Thanks a lot.
Thank you, Kiran.
Yeah, thanks a lot.